Today we're going to work with multiplying polynomials. And we did some multiplying polynomials last week. We were working specifically with multiplying binomials. So let's start there. Let's try a warm-up problem multiplying binomials. Remember, a binomial really just means there are only two terms. So something like x plus 2 is a binomial. There's two terms there. We're going to multiply that by the other binomial, 2x minus 3. So we said last week when we're doing a problem like this, what we're really doing is the distributive property. I'm going to take this x and distribute it to the 2x and the negative 3. So let's do that. X times 2x is 2x squared, and x times negative 3 is minus 3x. And then I'm also going to distribute the 2. So I'm going to do 2 times 2x and 2 times negative 3. Well, 2 times 2x is 4x, and 2 times negative 3 is negative 6. And then the last thing I have to do is just look for like terms to combine, which we have right here in the middle. Negative 3x plus 4x would be 1x. So my answer would be 2x squared plus 1x minus 6. So that's what we did last week. Today what we're going to look at is, well, what happens when we have a polynomial that's bigger than just a binomial, something with more than two terms? So for example, if I look at this problem, I've got the binomial x minus 3, but now we're multiplying it by a trinomial, x squared plus 2x plus 4. It has three terms. But when we do a problem like this, if we're multiplying polynomials bigger than just binomials, our strategy is still going to be pretty much the same. We're still just going to distribute. So if I want to multiply this problem, I would still take each of the terms in the binomial and distribute it to the trinomial. So I would do x times x squared, x times 2x, and x times 4. So let's go ahead and start there. X times x squared. Well, this is really 1x times 2x's, so there's a total of 3 x's being multiplied. That's x to the third power, or x cubed. Then x times 2x would be plus 2x squared. Then x times 4 would be plus 4x. So I distributed the x to all three terms. Next, I'm going to distribute this negative 3. Remember that minus sign goes with it. So I'm going to do negative 3 times x squared, negative 3 times 2x, and negative 3 times 4. I'm going to distribute negative 3 to all of those. Negative 3 times x squared is minus 3x squared. Negative 3 times 2x is minus 6x. And negative 3 times 4 is negative 12. So I really did 6 multiplications here. I've got x to the third plus 2x squared plus 4x minus 3x squared minus 6x minus 12. And just like the last problem, the last thing we have to do is look for the like terms to combine. Well, there's more terms here, so we have to look a little more carefully. So first term is x cubed. I don't see any other x cubed, so I'm just going to bring that down. Next term, 2x squared. Well, yes, it has a like term right here, negative 3x squared. So I need to combine those. When I combine 2 and negative 3, well, 2 minus 3 is negative 1. So that's minus 1x squared. Now go to the next term, 4x. Well, it has a like term right here, negative 6x. So if I do 4 minus 6, that should be negative 2x. And then the only term we haven't used yet is this minus 12. It doesn't have a like term, so we're just going to bring it straight down. So our answer this time is x to the third power minus 1x squared minus 2x minus 12. Now I also want to show you another way you could do this type of problem. This is called the box method. Because when we're distributing this many terms, it's kind of hard to keep organized. There's a lot of multiplications going on. This box method is really the same process, but it might help you keep it a little bit more organized. So let's try another problem and I'll show you how to use the box method. So for this problem, we're going to take 2x plus 1 and multiply it by 3x squared minus 5x minus 2. So again, it's a binomial with 2 terms times a trinomial with 3 terms. So if I'm going to multiply these using the box method, I'm going to start by drawing a box. This box is going to have 2 terms on one side, 3 terms on the other side. So it's going to be kind of a rectangle. And then I'm going to divide it into basically a 2 by 3 rectangle, because I'm doing 2 terms times 3 terms. On the outside of the box, I'm going to put the 2 polynomials. This one is 2x plus 1 is the binomial, so I'm going to put that on the side of the box that only has a width of 2. And then across the top of the box, I'm going to put the trinomial. 3x squared minus 5x minus 2. So now I have my box set up. I've got my binomial along the side, my trinomial along the top. Now within each little square, I'm just going to multiply the number to the side and the number above. So in this first box, I'm really doing 2x times 3x squared. Well, 2 times 3 is 6. X times x squared is x to the 3rd power. Now go to the next box. Multiply the number on the side times the number at the top. So 2x times negative 5x. 2 times negative 5 is negative 10. X times x is x squared. And now if I go to the next box, multiply the number at the side times the number at the top. So 2x times negative 2 is negative 4x. And then the next row should be easier because I'm just multiplying by 1 every time. So I'm going to do 1 times 3x squared. Well, that's just 3x squared. Then 1 times negative 5x is negative 5x. And 1 times negative 2 is negative 2. So if you look, I really did the exact same thing I did up here. I multiplied each of the 2 terms in the binomial times all 3 terms in the trinomial. I just did it in a little bit more organized way. And then the nice thing about the box method is it makes combining your like terms really easy, because if you look for your like terms, they're always going to be diagonal from each other. So for example, right here, negative 10x squared and 3x squared are like terms. They both have x squared. And then the same thing here, negative 4x and negative 5x are like terms. They're diagonal from each other. So when I go to combine my like terms, well, the 6x cubed didn't have one, so that's going to stay the same. Negative 10x squared and positive 3x squared, when I combine those, negative 10, positive 3, I should get negative 7x squared. The other like terms, negative 4x, negative 5x, when we combine those, that should be negative 9x. And then the negative 2 didn't have a like term. So I'm going to keep that negative 2. So the answer here is 6x cubed minus 7x squared minus 9x minus 2. So with the box method, we still do the same 6 multiplications. It's just a way to keep it a little bit more organized. And then it's a little easier to find your like terms because they're on those diagonals. So I've got one more example problem here I'd like you to try on your own. You can use either the distributing method or the box method, whichever one you think you feel more comfortable with. Maybe try it both ways to get an idea for which one you feel more comfortable with. So go ahead and pause the video, try the problem, and press play when you're done to check your answer. All right, let's check your answer. I'm going to work this problem out using the distributing method like we did in example 1. So I'm going to distribute x first to all 3 terms over here. So x times 2x squared is 2x cubed. X times negative 4x is negative 4x squared. And x times 1 is 1x. Next, I'm going to distribute negative 4. So negative 4 times 2x squared is minus 8x squared. Negative 4 times negative 4x is plus 16x. And negative 4 times 1 is negative 4. And then lastly, I'll look for my like terms. 2x cubed doesn't have one. Negative 4x squared minus 8x squared should be negative 12x squared. 1x plus 16x is plus 17x. And the only term left is the minus 4. So 2x cubed minus 12x squared plus 17x minus 4 would be our answer here. So we're multiplying polynomials. It's a little bit more work than multiplying binomials, but we're still basically just distributing.